Hi, in this video, we'll build a CLI application using Go and test-driven development. Let's start by creating a new module called Todo. We'll begin with creating tests for adding items to our to-do list. We need a function called new to-do list. The add function will take a title as input. I'll install the Testify module to make our assertions more readable. The first assertion confirms that one item has been added to the to-do list. The second one confirms the item is exactly what we intended. To fix the compilation error, we need to create a new to-do list function which returns a pointer to to-do list. We'll define the to-do list struct and then to-do item struct. Now we need to define the add function. I'll use VS Code to generate a function skeleton. I'll simply append a new to-do item to the item slice. Let's run the test. My mistake, I forgot to wrap the slice in the len function. Let's run the test again, and it passes. This add function is currently limited to the to-do list struct. I want to use it in the CLI, so let's create a test for that. I'll assert that error is nil and the output should contain something that confirms a new item was added. Now let's fix the compilation error by creating new CLI using VS Code. I'll create a CLI struct. And now I need to define the execute function in the CLI. It takes a slice of arguments. The test fails. Let's fix this by creating a switch case statement over the first argument. If it's add, handle add will execute. If the length of args is less than 2, that means the user hasn't entered a title. Otherwise, we'll assume everything after add is part of the title. Now the test pass. Next, we'll implement functionality to list all to-do items via CLI. I'll copy the code from the add test. If the command in CLI is list, we should get the entered title, the index number of the item, and the checkbox indicating if the item is complete or not. The test fails as expected. Let's add another case in the execution function. The handle list will generate output using string builder. The check mark will show if the item is completed. If there are no items in the list, the function should show an error. Now the test passes. For the first time, let's try to run the CLI application. For that, we need to define a main function. This will be fairly easy as we have implemented all the logic. Now, I'll build and run the to-do application. After adding the items, the program forgets about it because there is no persistence logic. For that, we'll use JSON files to store data. We'll create a test file. We will test functionality to save and load the data from disk. The storage will be used to save and load data. Using os.stat is a very common way to check if a file exists or not. We'll read the file to see if the item we added exists or not inside the JSON file. We can remove the os.stat logic as we are trying to read the file. Let's create the storage.go file. Let's create the new storage function that returns pointer to the storage object. We'll define the storage struct. Now we'll implement the storage logic. In the function, we'll use Marshall indent function from the JSON module. It returns the byte string. We'll check for the error. Then we'll write the byte string into the file. Now the tests pass. To see the JSON file, I'll comment the os.remove function call. Here's the JSON file. Next, let's test the load logic. I'll copy the code from test save. After saving the to-do list, we'll load the data into a new to-do. We'll assert the data in the new to-do is same as the old one. Let's check if the length of the old and the new to-do lists are same. And also check the first item in the new to-do list. Let's use VS Code to implement a storage.load function. We'll get data from the JSON file using decoder. We'll use new decoder.decode function to convert JSON file into to-do list struct. Let's run the test. I should have added items dot title. Now the test pass. I'll define file name as a constant. Now before executing any command, I want it to load the data from file. And I will defer the save method to be executed at the end of the function execution. Let's try to run the program again. Now, if we add an item, we are able to view it in the next execution. Now when we run tests, they are failing. Let me take the file name as input in the execute function so the same file may not clash between different tests. I'll generate a random string from the timestamp so the file names are unique for each test. Let me delete all extra files. Let's write logic to remove or delete the test files. We have to update the main method as well. Now the test pass. The extra files is not being deleted for some reason. The error is because I forgot to close the open file after reading. Now everything seems to work. This completes our basic framework of the to-do list CLI application. Now we can incrementally add more and more features as we needed. Let's implement the feature to complete a task in the to-do. Let's use code from test add item. We'll have a function to complete a task with a given index. Let's implement the complete function. Now we'll add the feature in the CLI. The user will give us a 1 based index and will convert it into 0 based. The done should be true. Let's work on fixing it to pass the test. Ensure there are at least two arguments. We'll extract the index using scanf. We should also check for the index out of bound cases, but this will do for now. Now we can complete tasks as well. Let me just fix the new line issue. In the same way, we can add features to delete the task, modify the title, view incomplete tasks, etc. But this is it for now. Thanks for watching.